First, let's start with the atom. Atom has nucleus. Inside the nucleus we know protons. That's why nucleus of the atom is positively charged. But electrons are revolving around the nucleus in circular orbits. We know from the Bohr model, and also the same thing is said in the Rutherford model. And these negatively charged particles are kept in some orbits by an electrostatic force between the positive charged nucleus and electron. We know that positive attracts negative, and this centripetal force keeps these electrons in circular orbits. So the electrostatic force between the electrons and nucleus, which is positive, binds electrons to the atom. But there are orbits. Some orbits are closer to the nucleus, some are farther. As distance increases between these two charge, positive and negative charge, so as distance increases, magnetic force decreases. As for this magnetic force decreases. If the distance from the nucleus increases, the electron becomes more loosely bound to the atom. Yeah, closer electrons are strongly bound, but far electrons are weakly bound to the nucleus of the atom. So those electrons at the outermost orbits, farthest from the nucleus, called valence electrons. Valence electrons. The outer shell electrons. Outermost orbit electrons.
Or the last chemistry.
Yeah, first, second, third, fourth, and last. Farthest from the nucleus of the atom. That's why they are farthest. They are bound with the weakest force or weakest energy, called valence electrons. These valence electrons determines a substance can be insulator or conductor. A conductor has large number of these electrons, valence electrons, which are mobile. Mobile means which can jump from one atom to the next. So a small electric field, yani a battery, when you connect a battery to this conductor, a small electric field can start valence electrons to move from atom to atom, from atom to atom, which means electric current starts, conductor starts, conducts electricity. But for insulator, it's not like this. These valence electrons are unable to jump from atom to atom. They are immobile. They cannot. So, which means insulators, no electric current. An insulator cannot conduct electricity because those valence electrons are unable to jump from atom to atom.
Teacher, by free electrons, it means valence?
Valence, yes. For conductors, they are free, but for insulators, they are not. They cannot go jump from atom to atom for insulators. But still, we are talking about valence electrons because they are outermost electrons, which affects the conductivity. And according to this model, behavior of the atom's valence electrons determines the chemical properties of the substance. Yani it's an insulator or conductor depends on behavior of valence electrons. Other electrons we don't care. You see that? There are several electrons at several orbits. First, second, third, last one is important. That's why we don't care. This sphere, which is full of other inner electrons, inner orbit electrons, and also nucleus. We don't care. We care behavior of the last outermost electron, which is valence electron. So inner electron shells and the nucleus can be thought as a single point charge surrounded by valence electrons. This model is successful to some extent. We can understand why a substance is insulator, why a substance is conductor, but no explanation about why some substances are best conductors, why some are not that good. For example, silver is best conductor, copper is the second best. Why second best? Iron is not good conductor. Why not good conductor?
Because of the valence electron.
The answer in this model. There are insulators, conductors, and also semiconductors. So why some are semiconductors? So no answer again. Then this model, what I explained, cannot explain those things. Yani it's a model, but Good enough. So, a new model is required for explaining what those things which I said to you. That model is known as band theory. So one model used to understand why solids falls into categories of conductors, insulators, and between them, semiconductors. Or silver is best, copper is second best, aluminum is other one, but why? There is an answer. So that's why we need a new model, and this model is band theory. Now I am going to talk about the band theory. What is it? Identical atoms have identical energy level diagrams. We know this. From Bohr model, we learned. So, ground state, n is equal to 2, n is equal to 3, 4, 5, and so on. So these are representing energy level diagram. So you can excite an electron from first to second, first to third, first to fourth, first to fifth, depending on how much energy you gave it. Just single atoms diagram is this. But in solids, billions of atoms together, not only single atom. So, as the atoms are brought closer, when you bring them closer, to form a solids, their energy levels overlap because they are same type of atoms. Atom 1, atom 2. Ground state, same energy. First energy, second energy level, same. Third, same. Fourth, same. Fifth, same. There is a rule in physics and also chemistry. It is this. Because no two electrons in the same system can occupy the same state. Yeah. Electron of this atom, an electron of that atom cannot stay at the same energy level when you make them closer, because both are negative, they start to affect one another. That's why these energy levels slightly shifts. One level moves a little up, other one moves a little down, but very little. Very little. Just like this. When two atoms get closer, each energy levels split into two different energy levels. Two atoms. We make them closer. This is the atomic separation, how distant they are. This is representing energy levels. Initially, as I said, they are so far from each other. For each atom, we have same energy levels. Yani, n is equal to 1, say that 1.44 both of them. N is equal to say that negative 2.74 both of them. But when you make them closer and closer and closer, from a distant on, this energy level starts to split into two. One line represents energy level of the one of the atom, one of these two atoms. Other one represents energy level of the another of these two atoms. Each energy level splits 1, 2, 1, 2. What if we approaches 4 atoms together? When more atoms get closer, the energy level splits so many times. For example, we make 4 atoms closer. Until a distance, each atom will have same energy level because they are far from each other. So n is equal to 1 for atom 1, atom 2, atom 3, atom 4. N is equal to 2 for atom 1, atom 2, atom 3, same types of atom they are. But after some distance, when they make them closer and closer, this time, this n equal to 1 starts to split into 4 slightly different energy levels for the first atom, for the second atom, for the third atom, for the fourth atom, because there are 4 atoms. For second energy level, for the first atom, second, third, fourth, and so on. But solids are composed of billions of them, not only 4. Billions of atoms are closer. So we are going to divide the single energy level into billion times. Billion times you should divide it. When you divide them billion times, what happens? It becomes a band. Band. So when many atoms are bound together in a solid, the clearly defined energy levels of the single atoms widens and blurs into an energy band. So this is called a band. So n is equal to 1 when the atoms are far from each other. It was just single line. When you make them closer and closer, so this energy level splits billion times it splits. When it billion times splits, it becomes a band. Second energy level, when they are far from each other, it's a single line for each. But when they make them connect, so it splits billion times, it makes a band. In short, in atoms, we have energy levels. In solids, we have energy levels. In atoms, we have single atoms, we have energy levels, but in solids, we have energy bands. First energy band, second energy band, third energy band, first and low energy bands, just like in Bohr model, and low energy levels we have. First or and low energy level. Energy equal to 2, second and low energy level. Energy equal to 3, third energy level for single atom. But now, instead of energy levels, we have bands. First and low energy band, second and low energy band, third and low energy band, fourth and low energy band, and so on. And in Bohr model, also there was a difference between each energy level, correct? Between energy equal to 1 and 2, there is a separation. 2 to 3 is a separation. And we said that electrons can never be found between these two energy levels. Similarly, electrons can never be found between these two energy bands. That's why this separation is known as forbidden energy band. Electrons cannot be in here. Will be here, or will be right there, or will be right there. First, second, third, whatever. Highest low energy band occupied by the electrons is known as valence band. Neden? What? Because valence electrons are right there. First energy level, second energy level, third energy level, last energy level. Valence electrons are in last energy level in an atom. For a solid, where are they? At the last band. The highest and low energy band. First, second, third, fourth, and then last. Last and low energy band occupied by the electrons is known as valence band. Between each energy and low energy band, there is a separation. This separation is called forbidden energy gap. Why? Because electrons cannot be found between these two.
So this happens because of the repulsion of electrons?
Yes, it won't be, because of the repulsion of the electrons from another. Just like in Bohr's model, we have energy levels. In solids, we have energy bands. In Bohr model, first energy level. In here, first energy band. Second energy level, second energy band. Third energy level changes to third energy band. Between them, forbidden gap. Because electrons can never be found between two energy levels according to Bohr's model. And here also same thing. An electron can never be found between two low energy bands. Which is called forbidden energy gap. And I said that the most important energy band is the highest band where the valence electrons exist, containing occupied energy levels known as valence band. But above this valence band, there is one more energy band, but it's not occupied. There is nothing. Empty. This unoccupied energy band is given a name. Conduction band. Conduction band. Additional but unoccupied. Empty. Band of high energy besides the valence band, and above the valence band, is called conduction band. And between these two bands, there is a forbidden energy gap, where electrons can never be found. And between these two, the range of the energy between the valence and conduction band is called band gap, forbidden band gap, or forbidden energy gap. Now you will understand why some substances are insulator, why some are conductor, why some are semiconductor. By this model, you will understand.
For the last energy band is above the valence last.
Yes, which is conduction band, is empty.
Okay.
Empty, unoccupied is empty.
Each band have given a name? A specific.
Only two we care. Valence, which is the highest occupied one, because there are lowest as well. We don't care the lowest. We care the highest occupied one, which is called valence, and next one, conduction. Solids according to size of the energy gap, yani band gap, solids falls into categories of insulator, semiconductor, and conductor. And how? This is the model for a insulator. Valence band and conduction band. You know what is the gap between them? 5 electron volts. If you want to start the conductivity, electrons in the valence band must jump to conduction band. But this gap is huge, 5 electron volt. 5 electron volt energy cannot be gained by an electron. That's why these electrons in the valence band can never jump to the conduction band. That's why insulators never conduct electricity. Yes, never. So the gap is so large between the conduction band and the valence band, that is unlikely that an electron could ever gain enough energy and move from the valence band to the conduction band. So no conductivity. But look at the second one. Semiconductors. Look at the gap. Gap is 1 electron volt. So compared to insulators, it's small. So these semiconductors could be conductors if you are able to make these electrons gain 1 electron volt energy. An electron could move to the conduction band from valence band if it gains enough energy. But how can you make it?
What temperature?
Yes. Do you remember that? There are 3 methods. 3 methods of the adding energy to a system. One of them is passing electric current. Second one is using photon. Third one is heating. When you heat semiconductors, electrons of the semiconductor gains this 1 electron volt energy, they jump on the side, conduction band, and then conductivity starts. For that, the semiconductors are good conductors at high temperature, insulators at low temperature. What about conductors? In conductors, separation between conduction band and valence band is too small. Too small, 0.005. Even they are coincide, side by side. This is conduction band, this is valence band. For insulator, that gap is so huge. Semiconductors, they are close. But for insulators, for conductors, sorry, so they are side by coincide. Ne demek? Very small electric field, yani battery, can provide that small energy to these electrons, make them jumping from valence band to conduction and conductivity starts. So there is essentially no gap. Yani, is there a gap between my terms now? A little, but essentially no.
It's only between these two, but
Yes.
or the others as well.
For conductors. For conductors. So no gap between valence and conduction.
But they still need energy, just a bit of energy.
Very little energy, 0.05 electron volts, and then keep provided by a battery is easy. When you connect the battery to a conductor, electric current starts, and conductivity starts. Yeah, the valence and conduction bands overlap. Valence band is also conduction band that is partly filled. And electrons can be excited into a conduction band by 2 ways. One of them is atomic excitation. Yani we are going to heat semiconductors. Electrons may be thermally excited into conduction band rather easily in the semiconductors. Thus, the conductivity of many semiconductors improves rapidly with temperature. As temperature increases, their conductivity increases. But this makes semiconductors poor conductor at low temperature, but good conductors at high temperature. But for conductors, only battery is enough. Use a battery. Connect the battery at the end of the conductor. As soon as this you apply the battery, because we know that every battery produces electric field from positive to negative, and this electric field starts the electrons jumping from valence band to conduction band. When electric field is applied to the conductor, it does work on the electrons to move to higher energy band, so conductivity starts instantaneously in a conduction. Section 1 is over.